Hi everyone, today we're looking at question 30 from College Board Practice Test 2, Section 4. Now question 30 is a little bit difficult because it lets us keep track of three separate concepts that we learned over the years. First being the property of a regular polygon. Next we need to know how to find the area of a triangle. And lastly we need to know the properties of special right triangles. These concepts are going to come together in what I call the SAT math stack. This is a list of concepts that will help us keep track of what steps we're taking to solve this problem. So let's dive right in. Question 30 says the figure above shows a regular hexagon with sides length A and a square with side of length A. If the area of the hexagon is 384 times the square root of 3 square inches, then what is the area in square inches of the square? And as you notice, I'm starting to color code some parts of this problem for us. You won't be able to do that on the real SAT, but it'll be helpful to keep track of our steps. So the first thing to note is that we have a regular hexagon. And why is that important? Well, a regular polygon has equal sides and therefore equal interior angles. To find the value of one of these interior angles, we need to first find the total, or the sum of the interior angles, using the formula n minus 2 times 180 degrees. This will give us the sum of the interior angles. So for a six-sided polygon, we'll substitute that in for n, multiply by 180, and that gives us 720 degrees. Now to find the angle measurement of a single angle, we'll divide that by 6, and we'll get each angle equaling to 120 degrees. That becomes important because the next step for us is actually to divide this hexagon into 6 equilateral triangles. In doing so, we can actually isolate one of those triangles, the one that shares a side with the square, and that'll help us calculate the total area of the square. So over here, we're going to find the area of a triangle, which we know to be 1/2 base times height. This will be given at the front of each test packet. And I'm going to draw this triangle a little bit larger here for us, just so we can see some of the properties that we're working with. First thing to note is that this top angle is 60 degrees. We know that because we bisected the 120 degree angle from the hexagon. I'm going to go ahead and label this side, which is A, as our base, and therefore the height of this is going to be a perpendicular line to the highest point of the triangle. In drawing this height, we've actually created a special right triangle. So I'll go ahead and erase the bottom half and focus on this special right triangle, which is a 30, 60, 90 triangle. Also referring to the equation sheet at the beginning of your section, we know that 30, 60, 90 triangles represent a proportion of x to x root 3 to 2x in terms of their corresponding sides. So we'll table this A for now, and we'll actually label this triangle with the corresponding sides, which are going to be across from the angles. So x root 3, and then across from the right angle would be 2x. Now that we have a proportion set up for all three sides of the triangle, we could use the equation A equals 1/2 base times height, and substitute base with x, and substitute height with x root 3. Now we just need to find the actual area of our triangle. So we started, if you remember, with 384 times square root of 3 square inches. That was the total area of our hexagon. If we divided that by 6, we would have gotten the area of one of our one of our equilateral triangles, which would be 64 times the square root of 3. Now, because we then cut that equilateral triangle in half to create a 30, 60, 90 triangle, we'll divide that by 2, and that'll give us 32 times the square root of 3. So I can go ahead and plug that in. By the way, special right triangles, the property is down here in green. So I'm going to get 32 root 3 equals 1/2 x times x root 3 Following some steps of algebra, we should get 32 root 3 equals 1/2 x squared root 3. We notice our root 3's will cancel out. And if we multiply the 1/2 over, we go ahead and get 64 equals x squared, meaning that x equals 8. Now this isn't our final answer because if you remember, x was only part of this side here that actually was the representative or the shared side of the full square. So going ahead, we say x is 8. That means that this is also 8, which means that a over here is actually 16. And if that's the case, the area of our square, which would be a squared, is 256. Thanks for joining us today for another problem on IntelliGEMS Math Mondays. If you have any additional questions about this problem, please feel free to reach out in the comments.